Hi, hello friends. Welcome to Unacademy. Welcome to my classes. And in this session, we are going to see some of the different examples which were not discussed in the earlier sessions based on how you can able to do the mapping from conceptual model to relational model. It is nothing but minimization of your ER model into relational model. So before starting the session, let us say our anthem. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. Dear friends, Unacademy has created a wonderful interface with a top quality content to serve the dedicated students to clear all your goals because your goal is Unacademy's goal. And dear friends, myself is Srinivasrao IS, having more than 15 years of experience in the GATE with the various subjects. Also had industry experience with the relevant good certifications. Friends, throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of my students got settled in higher positions just by completed their post-graduation from India's premium institutions like IITs. So, to crack the GATE examination, there is a requirement of tips and shortcuts and do's and don'ts and some guidance from senior most faculty members. Because GATE examination is a completely negative marking approach, there's a lot of confusion and diffusion you may feel. So that's why to get the proper guidance and tips and shortcuts, give your valuable admission into Unacademy using my referral code. Then you're going to get the content from the Unacademy and the guidance and the content from myself also. Many of my alumni is working in the topmost companies and topmost PSUs. Some are also parallelly doing their GATE mentoring. So you also can do just get the complete in-depth learning, in-depth knowledge in each and every subject. Then you also can achieve such kind of goals. So Unacademy has launched two different unique programs, Plus and Iconic. So once you become a Plus member, then you're going to see that unrestricted access from Unacademy student learning app. Because many of the things we are going to discuss in the special classes and in the Plus courses, which we may not do. So that's why, please all of you, convert your admission into Unacademy either by taking a Plus course or Iconic subscription. So once you become a Plus member, you're going to see the dedicated lectures, live sessions, live classes, mental ability sessions, and many things. Whatever is there in Academy, you can unrestrictedly access it. And what is Iconic? Iconic is inbuilt consist of a Plus program. Apart from that, you're also having 1:1 personal coach. So friends, utilize this unique opportunity. You're going to get 1:1 personal coaching. So to get, there are few kinds of subscriptions, 12 months, 18 months and 24 months. So friends, use my referral code to get the admission into Unacademy. So current fourth year students can prefer a long term. Second and third year students can prefer mid-term, that is 18 months, and 24 months. The super long term can obtain by first and second and third year onwards. The first year students also can start taking the GATE program because you're going to do a critical subject called data structures and followed by flat and compiler design DBMS networks operating system. That's why you start doing with the CN data structures. So after using my referral code, you're going to see that the final prices in the plus course are like this. And the other kind of a unique program, the subscriptions are an iconic subscription. That's a 12 months and 24 months. Current fourth year students can opt for this, and super long term first and second and third year students can opt. And my referral code is also eligible for any kind of a course which is there in Unacademy. So dear friends, after applying my referral code, then you're going to see that these are the final subscription prices. Friends, let us start today's session with the mapping rules. How you can do mapping rules, how we can able to do minimization. So I will tell you one sample example why we have to do minimization. I said there is an entity E1 and entity E2. They are trying to share a relationship. The relationship name is R1, which is with 1:many direction. So the E1 is talking minimum cardinality, maximum cardinality. He is asking maximum number of tables you require. So the maximum number of tables you require for this given ER into relational model, there is a requirement of entity 1 and there is a requirement of entity 2 and there is a requirement of create R1 also. This is a maximum number of tables you need. But this you can do using a what? Merging. So what is the merging? Minimization of your ER. So when you talk minimization, there are many rules to do minimization of your R. So minimization of ER is nothing but a reduction of your tables into relational model. So instead of doing E1, E2 and R1, what I am going to do? I will do E1 and I will do only E2. But this relationship we are not going to make a separate table because this I can use a merging with the other side. So which side to be merged? I am going to give you the rule. According to the rule you need to follow. Always the merging is supposed to be followed using the rule, that is the meaning. So this is a benefit. What is that? Maximization versus minimization. So minimization of ER takes some kind of rules. According to the rules we do the minimization without loss of your ER model. Data is not going to be lost and its behavior is also not going to be lost. But the thing is that instead of creating several tables like E1 and E2 and R1, instead of representing 3 in your relational model, space waste and a time complexity also, that's why I'm taking only E1 and E2. Two entities are sufficient, that is equivalent to your maximum number of tables. So how you can able to do this mapping, we will see. So rule number 1, first it is talking about entities. Create tables for separate tables. While I am doing minimization, please observe. Create a separate table for strong and weak and associative entity, no doubt. And coming to the attribute, create a separate attribute for strong, weak, single, simple, stored attributes. And coming to composite attribute, we will not create a composite attribute, we know. Just we create only simple columns of your composite. So this is how to convert into relational model according to composite columns. According to strong, weak, single, simple, store, you must represent in relational model, otherwise it is going to be a data loss. According to entity, you need to create a strong entity and you need to create a weak entity and associative entity, otherwise there is a data loss. And according to derived attribute, do not maintain any kind of attributes for derived attributes because they are nothing but formula notations only. That's why do not create any separate attribute for derived. And you convert multi-values into single values before you are making into relational model, because a relational model is not going to allow any kind of multi-values. That's why you have to create a separate table for multi-value attribute. This is mandatory because a relational model is a dead against with your multi-values and composite data. So do not create a separate attribute for multi-value. Instead of that, create a separate table for multi-value column along with its key attributes. That's very important. And when you talk about derived attribute, do not create a separate attribute for derived attributes. And do not create a separate table for 1M, M1 relationship, because I can do using a what? Merging. So we will use a merging table with the M side. But you cannot do merging operation with M is to M. You need to create it a separate M is to M table. Last session I discussed. So you need to create a separate table for associative entity. So friends, using these rules, let me discuss few examples. You need not by heart these rules I am saying. Example itself will give you lot of confidence and trust. So according to generalization, specialization and aggregation, how you can able to convert into relational model. For generalization, create high level entities first followed by low level entities. For specialization, create a low level entities and followed by high level entities. And for aggregation, remove redundant relationships. So let me discuss an example. So what this example is saying, there is an entity E1 which consists of A, which consists of B, which is derived to C and D, which is derived to E. So he is asking what is the equivalent relational model. So when you talk about equivalent relational model, create a E1 and entity is supposed to be created as a separate table. E1 consists of key attribute, derived attribute we will not create, and don't create this, and C and D. So this is the equivalent relational model to the above given ER. Because you know the rules. What are the rules? Derived attributes we least bothered and composite attributes we least bothered. And while doing, now you see, the example is speaking like this. So there is an employee entity which consists of employee number. Please observe every example, which is a dotted. That means this is a weak attribute and this is a weak entity. and which consists of employee name. My question is, can we represent EMP alone? So the answer we say that no, because every weak entity must depends on strong entity. When you look at another example, there is an employee entity which consists of employee number, which consists of department name. This department name can have multiples. Now he is asking, what is the equivalent relational model? Observe now, this is a very important question. As usually, we do create an employee and there is a key attribute, a strong attribute. I am creating it. This is your employee table. So multi-values according to relational model cannot be represented in relational model. Therefore, what is required? Create a separate table for multi-value column, that is a D name, which consists of the multi-values along with these multi-values belongs to this keys. Make a composite key. So according to that, there is a requirement of what? Two relations. Now let us see another example. So when you talk about department entity and employee entity, two entities are there. This has got department number key. This has got employee number key. This has got employee name and employee date of birth and employee age. So department and department name and LOC, location. LOC stands for location, is a multi-value. So now he is asking, this is your ER. We want to map to RM. How? The first entity you are going to create DEPT, a department number. So don't involve LOC in the table because MVD's multi-values cannot be represented in the table. You need to convert your multi-values into single values by making a separate table. So location, the field name is a location and these locations are belongs to department number. This and this is your composite key. According to this RM, we want employee instance. The column name is employee number and another column name is E name. Another column name is a DOB because a simple, single, stored, strong, weak, all we want to create a separate attributes. But age we ignore because it is a derived. Derived is nothing but a small notation we are not going to consider and create in a relational model. So this is about a representation of almost all MVDs, composite, simple, single, strong. Now we need to talk about some examples on weak entity. First, let me show you the relationship carefully. Now I'm talking into 1:m relationship. How are you going to convert or how are you going to map into relational model? So there is a department entity in your ER which consists of department number and this consists of department name, an employee instance which consists of employee number and which consists of employee name. You please observe one important point. This is a strong entity as a key column is there. This is the strong entity as a key column is there. Now they want to share the data. How they are participating? A department can have more than one employee. A department can have more than one employee. A department can have more than one employee. So I'm writing 1:m relationship. The relationship name is works. A department consists of multiple number of employees. This is your ER. You need to map to relational model. So forget about the structure and the length of the structure. You focus on rules only. These are the shortcut rules. What is the rule? Create a separate table for strong entity, weak entity, associative entity. So both are strong entities. So DEPT instance and employee instance. I am ready to create them. Both are strong. So create a separate column for strong attribute, stored attribute, simple attribute, single attribute. Therefore DNO I need and dname is also I need, because we will not focus on to derived attribute and create only subcolumns of your composite and create a separate table for multi-value. Remaining columns you need to create it. This is fine. Now employee table consists employee number and employee name. Now as I told you, maximum tables you need 3 because the relationship is also to be created. But the meaning of minimization of ER into relational model we are doing according to the rules we follow. What is that? Merging. You can do merge the relationship because I told you. So 1M can be merged, M1 can be merged, and 1 can be merged. So use the merging rule. So therefore what is going to happen? I am merging this works with the employee. Therefore what is going to happen? This particular key attribute will be adding here. Hence you are going to get one of the column from other instance. If at all you are having a data of joining field, the relationship consists a descriptive attribute. That data of joining also you supposed to add without any loss of data where you are merging. As we are doing a merging this side, so you supposed to follow the same. So this is the structure of 1:many with 2 different entities. So when I am talking about another example, so there is a course entity and there is a student entity, and which consists of the relationship between them join. A student can join for many courses. A student can join for many courses, and a course can have only one student. If I write like that, a student can join for many courses and a course can have only one student. So there are some attributes are there inside. Course number and a course name. So multiple courses are there here. Student number, key, and student address. The address consists of door number, flat number, and one more information also I want to record, that is mobile number. Now you tell me, So what is the equivalent relational model? So when you talk equivalent relational model, first as per rules, create both the entities. Course I am ready to create, students also I am ready to create. So let us create a normal columns. CNO is a strong attribute, create. CNAME is not strong, it is a multi-value attribute, so we need to separately make it. Course name, which consists of course name field, and these course names are belongs to course numbers. Now this is done, this is done, this is done. Now come to student. So student has got student number, it is a strong. Address consists two derivations, therefore we don't concentrate on composite. Create its simple columns. And mobile number, I want to go for multiples. So you need to create a separate which consists of your mobile number, and these mobile numbers are belongs to student number. Underline. So the structure is also done. Now the left one is only a relationship. The relationship is m is to 1. What is the rule? So for 1 is to m and m is to 1 and 1 is to 1, you can use a merging rule. So I'm going for merging this side. Foreign key side I am doing merging. Therefore what will happen? This join, if it consists data of join, now we will merge in that side. Therefore course has got the key attribute of this into other side. Now the descriptive attributes also you supposed to bring it. So this is the relational model of the given diagram. If you talk 1 is to 1, one is to 1 relationship can be merged either side, no problem, can be merged either side. There is no prescribed rule for this. Same example we take. There is a course instance, there is a student instance. Now a course consists only one student, and a student can take only one course. Now what is going to happen? They are participating like this, 1 is to 1 relationship. So what is a relational model to this? You can have a course which consists of course number and course name if I have the fields. And if I take this side columns are student number and student name. Now the student table also I'm going to project. Student number, student name. Now come to the point join. So the join has got a field called attribute called DOJ, data of join. Now the problem with the relationship, where to join this? If it is 1m and m1, I can able to do the merging at other side, that is m side. But here I can able to do two cases. Case 1 merging left hand side, case 2 merging right hand side. So here 1 is to 1 relationship, both are using partial participation. This is very important. It's not compulsion because there are no two lines. It's not compulsion. Therefore, you can able to do the merging either side. So what is the case to write the same table once again? There is no change in case 2 also except small. So course number and course name. And here when you talk about the student, so student number and student name. So now the difference is how are you going to merge this relationship? If I merge this join with the course, then what will happen? So this side, so I'm writing, afterwards I will erase this circle. This side we are going to map. So what is going to happen? You got key column of right hand side entity into this side. And you also got a data of join here. That's it. We close it. So if I merge like this, the second answer is this join is merging with a student. So the left hand side key will join here. That's nothing but foreign key. So course number and the data of joining will come. So these are the two answers. Any answer is correct. Okay, friends. This is how 1:1 with the partial participation. So merging can be in either direction. Bring other side. One is nothing but primary key. One side, one primary key into many side. Then it is going to act as a what? Foreign key. Now this SNO is a foreign key here. And this ENO is a foreign key here as you are merging from that side to this side. If I do with, so many students used to ask me if it is total participation, what is the answer? So I'm saying 1:1 with the TP, total participation. So if you look at, there is employee entity and department entity. An employee can work only in one department and a department consists only one employee. But every employee must work in department. Every employee must work in department. So I can call this is a PP, this is a TP. The relationship name is a works. And both are 1 only. So how are you going to do the merging? This time you do not have to because you know total participation is weaker than your partial participation. That's why you follow merging always towards with the total participation in this case. So only one answer I am writing, that is what? Employee and department. So the department has got a few columns. If you take like department number and department name, and this has got few columns like employee number and employee name. So department consists of DNO and D name, and employee consists of E number, E name. Up to that we made what? Entities. Now you observe the relationship merging. So this time you need to merge because total participation is weaker than your partial participation. So merging in other side only. As the left hand side is a TP, then I am merging this. Therefore what happened? Employee is being extended as it is merged. So it is being merged. So whenever you are merging, the other side key is going to come into with you. If at all any descriptive attributes are there, we will take it. So this is how you can able to do 1:1 with the TP. So now I want to talk about weak relationship. So far we discussed about a strong. Now I am talking with the weak relationship. How you can able to migrate weak relationship ER into relational model. So there is a department entity and there is an employee entity. So both are participated in the relationship. So I'm making one is a strong, one is a weak. and this one employee number dot 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 partial key employee name, and the relationship name is works, and I am writing this is a 1, this is a M. Why? Because you know the situation why I have written TP there, because as your weak attribute is going to convert your entity into stronger weak, as a weak attribute is making your entity to weak. Now the relationship is also going to be what? Weaker. So how are you going to do this? So let us apply the rules. So create a separate table for strong and weak, a strong attribute and weak attribute. Let me do. Department consists a department number, department name, and employee consists employee number dot dot employee name. If it this consists data of joining, I am also taking, which is a simple or single or stored attribute. Now up to here we made department and employee. Now the weak relationship we want. So whenever you look at every weak entity and weak relationship is going to be total participation. So whenever you see a total participation, the merging is always weaker side. So employee has got a key column of either side with descriptive attributes. So this is the final structure of your employee and department after merging. Okay friends, and last mapping is M to M. So M to M cannot be done. M to M relationship conversion into relational model. So M to M relationship cannot be merged. You need to make a separate entity to this. Whenever I say an employee can work in many departments and a department can have many employees. So when you say this kind of a scenario, now what is going to happen? The relationship name is a works which consists DOJ. Now let us execute this. Employee has got employee number and employee name, and a department has got a department number and department name. Assume that there are no multi-values and there are no composite values, there are no derived values. Employee number and employee name. This is a department number and a department name. So as this is a MM, so you cannot merge as like 1M, M1, 1, you need to create a separate table. That's why this kind of entity is called as a what? Associative. Now I need to create a separate table works which consists employee number, department number, and your DOJ. So this is how you can able to do what? M to M mapping. If I ask an example like this, so almost all mappings we done now. Now I am mixing all together. Observe carefully. Entity E1, entity E2, it is participating in the relationship R1, and it is also having participation and there are some attributes here. Now he will ask you a question, dash number of tables. So when you say dash number of tables, according to our rules, you need to recollect. So every entity you need to create. So E1 we need, E2 we need. So this is a 1M. So not required. You can just simply go for merge. And this is a MM. So you need to create it, R2. So your answer is 3. Very simple. So using this knowledge, let us execute some of the questions which I formed for you. These are not gate questions. Gate questions we will discuss in depth in tomorrow's session. This session, first let us learn how to do the conversion process. So E1, E2 we want to create is asking dash number of tables only. So E1 first table, E2 second table, and this is a associative entity. So your answer is 3. So you want me to write the column structure? I will write it. E1 with A, B, C, and E2 with D, E, F, and your R with A and B. So this is your new structure. If you look at another example, department employee. So we need this table. We need employee 2 and we need associative entity. So there is a requirement of what? 3 tables into RM, relational model. If you look at another question, so this entity we need and this entity we need, and it is a MM relationship. We need this entity. So 3 tables after mapping. So this is a complex structure. You don't worry by seeing this much complex structure. Just we will use the rules and try to cut them. First rule, create a table for strong entity, weak entity, associative entity. Create a column for strong column, weak column, stored column, simple column, single column. Create a separate table for multi-value column. Do not create a composite column. Create only subcolumns of it. So these are the rules. Let us execute. First table E1. Second table E4. Third table E3. E2. E5. So you got almost all 5 tables. Now let us execute. Are there any multi-value attributes or not? Multi-value attributes, you create a separate table. So in E1 there are no multi-value, E4 no, E2 also do not have, E3 also do not have, E5 also do not have. So no need to create separate. Now let us look at the relationships. R4, it is a 1M, therefore not required, merge. And this is MM, this is required, 6th table. So this is a 1-1, not required. This is a 1-1, not required. That's it. Your total tables according to this. And this is also not required, R5, 1-1. So total altogether how many? 6 tables. You know the structure, how to draw E1 structure, E2, E3, E4 and E5 structure. Okay friends? And this is a TP, total participation. And this one is also required, R2. Please understand, R2 is a MN. Therefore, total 7 tables. So this is the total participation. So this is a total participation. Remaining all are partial. Now let us look at another question. So supplier we need, project we need. So one table, second table, this is we need, supply also we need. 4 tables right now. So let us see the relationship. First relationship 1n, not required. Second relationship is 1n, not required. Third relationship is n1, not required. So your answer is 4 tables. Remaining all you can able to do what? Merging. Remaining all you can able to do merging. So this is merged and this is also merged. Both are merged to supply and this is also going to be merged. So this is how it is to be done. So this is another example. So how many tables required? Employee manages department. Employee works in a department. And children of employees. Children are belongs to employees and employees are belongs to department. Those who are working. And employee managed departments. That means every department has a manager. That's meaning. So we don't mind about those kind of descriptions and all. Simple answer. Emp department child entity. This is a 1M TP not required. MM required. Fourth one. And this is a 1M not required. So your total tables are 4. So if you look at this example, so this is a multi-value. This is a strong entity. This is a weak entity. Yeah, this is also strong entity as a branch number is a strong attribute. This is your strong attribute. Loan is also strong entity because loan number is a strong attribute. So all are strong entities. So we want to identify how many number of tables. So bank we need and branch we need and loan we need. Now let us focus other multi-value attribute. We need separate table. 1n we don't require. 1n we don't require. And where else? So that's it. So only 2 relationships are there among them. Both are not required. You can use the concept of what? Merge rule. So this side, no? And don't create this bank name because it is a what? Derived. Now let us look at this. So dash number of tables. So we need E1, we need E2, and we don't require this, and we need this. This is one of your previous question. So your answer is 3. And this one you understand. So supplier we need, order we need, MM we need, and what else? So remaining all or simple and single attributes only. So therefore 3. And this one is a very good. This is a strong entity. We need this. As this is a strong entity, we need this. Amen. We need this. We need this. And we need this. You know why A3 and B3 are going to be separated from your B and A tables. A3 is separated from A because it is a multi-value. B3 is separated from B because it is a multi-value. And when you talk about this, E1, E2, E3. So 1 and 2 and 3 P 4, NM 5. This is 1 1, not required. M1 not required, and this is 1M not required. So your answer is, so altogether 5 tables: 1, 2, 3, 4, 5. So you know why I have cancelled R3, because 1M. You know why I have cancelled R2, because it is a 1M. Why I cancelled R4, because 1 1 self relationship. Why we took R1, because NM. So that's it, friends. So Unacademy is running successfully. Let's crack GATE ESE channel. Subscribe our channel. Hit the bell icon for latest notifications and updates. Use my referral code to convert into Unacademy. So I want to give you one task before closing this. So take this task and you tell me in the next session, that is purely problem discussion on ER model, different kinds of questions with the previous GATE questions. Now the task for you is like this. So entity E1, entity E2. So use all these diagrams, use all these examples and solve this. And this is R1, which is having A, which is having B, this is having a C, this is having a D, this is a 1 1 with the total participation M, N, O, P and Q. I want to ask you, this is a 1 1, both sides TP. So dash tables. So please do this task. One more task I am giving you. So before doing this, you please check whether it is valid or invalid. Don't directly blindly do. Sometime it may also give you traps, errors, may not possible. This is another task, MM with the TP. And E1 has got A and B. This has got C. This has got D. This has got E. So this example, you also please convert this example and previous example into relational model. And last task, please everyone, please do it. These three are very important questions in my case. Same structure I am taking E1 and E2. Relationship is like this. MM, the columns are same. A here, C here. The relationship name is R1, which consists of E multi-value. This is a partial participation, partial participation. So in this number of tables you need to calculate. In this number of tables you need to calculate if given ER is a correct. If given ER is not correct, you tell me that it's not correct. Why? In the tomorrow session. In this, whether this ER is correct or not, if it is correct, then how many tables you are going to get? So 3 tasks are given to you. Everyone please solve, because already you heard the lecture and you know the rules and regulations while conversion of your ER model into relational model. These three are excellent, three different examples. Okay friends. So let me add one more column. I'm making a bit complex. F2. Okay. So we will meet in the next session. Thank you for all your support. Any queries you can ask me tomorrow. Otherwise, you can chat with me. Thank you very much.